Hello and welcome to another tutorials of English education. In this tutorial I'm going to discuss Matlab Edge Detection algorithms. Now let's do some recap from last week. I discussed previously about few fundamental things which is really important for the beginners to practice. If you can avoid these mistakes, you can really short your learning curve and move forward. So the first one is check the version of Matlab you are using. Like my one, I'm using Matlab 2019. So this file you can download from the link provided. Will not work in 2018 version. The next one is know where your file is located. So make sure you put the right file path on the working directory. The third one is don't write your code in command window, and the fourth one is write your code in program editor, and the fifth one is be patient. Matlab is not a very fast language, so it takes time for the code to be executed. Okay, let's open a new file, new scripts, live script. I'm going to open the live script. When you open the live script, give it a name. So text, heading, title, now let's start the code. So the code button, give it a variable name a equal open an image file. So the command is imread parenthesis apostrophe the name. So I'm going to open this image file yahoo.png. so top png semicolon. Now I will convert this image to grayscale image. The command is RGB to gray, RGB to gray. As you can see, it's been highlighting there, so just click it. So which file I want to convert to grayscale? This a variable. So a, which is the yahoo.png image assigned for, again semicolon. Now I want to open both the file in side by side so that I can compare. So subplot that will be in one row, two column. So bracket one row, two column, and the image number I want to get is the first one. So image number will be 1, comma imshow a, give it a title name, title color image, semicolon, then another image. I will just copy the whole line, copy, changing the variable, everything is same, but this time I want the image to be the second one, so just changing to 2, and the variable is b, the grayscale image, b, title, changing the title grayscale, image, Now let's run the code. Okay, you can see side by side my image is color image and grayscale image. So this is a figure, 1 row 2 column. That's how you would write. Now let's talk about the edge detection. First let's discuss what is. So if you go to Google, so if you go to Microsoft Edge, just write what is image edge detection. So you get the Wikipedia page. So let's go to Mathworks. So the edge detection is basically locating the boundaries of desired object in another fundamental aspect of image processing. So locating the boundary of the image edge. So this is the image. This image shown here is a 120 by 120 pixel image. So it has got 120 column and 120 rows. The edge is detected. Basically the boundary of the image has been detected. Now how are you gonna apply this boundary? I would write IM tool B. So just run the section of the code. Here I can see my image. Now in this image, if you hover your cursor, you see the image is 255 by 255 8-bit image. It has got 255 rows and 255 column. So as you can hover your cursor, you can see here is a block. So the block, it has got the pixel number is showing, it is 63 row and 30 column pixel, and it is 0. This one, as you can see, this is 155 row and 18 column pixel. No, basically this is 155 column 18 row pixel. This one you can see is 47 column and 26 row pixel. Again the pixel value is 0. How about the white one? Here if you put the Y button, which is white color, you can see the pixel number is 80 column 109 row pixel, and the pixel value is 255. So the white is 255 and black is 0. So this is the pixel value. So we need to change the edge will be detected, the change in boundaries. So the boundary change happen here, this circle button, the boundary change here, the boundary change happen in the Y, the boundary change, different boundary change happen here. So what is the difference between the white color Y and this smiley emoji button? You can see the pixel number is 122 edge column and 149 row. The pixel value is 232. You can see it properly. The pixel value is 232. As you can go to the eye of the smiley face, if you can hover here, so it is black, but as it is not proper black, so the pixel value is 97. In this way So basically the program in the background, the following edge detection command I will be using, they will be changing, they will be detecting this change in the pixel value, and they will visualize it. So let's go back to our code. So there are different kind of edge detection. First I will use the Sobel edge detection. So Sobel, I'll go the variable name I give is C equal edge bracket B comma apostrophe. The name of the command is, as you can see, there are different Sobel, pre-wit, Robert, log, zero cross, Kenny. So basically you write any of the name. These are the main edge detection technique. So I write, let's write the Sobel, this name Sobel, S-O-B-E-L, capital S. Semicolon. Now let's open the whole thing in one figure with the black and white and grayscale. So the change it to one row, 3 column. So one row, 3 column. Copy this line. So change to column number 3. Our edge detected image will be located. So the column number 3 this time is C title Sobel image. Let's run the code. Here you can see the 3 image has been published side by side. So the color image, grayscale image, Sobel image. In Sobel image, so the edge is detected, is basically detected the change in the pixel values. So from here the black pixel value, which previously we have seen is 0, and different pixel value is more than 0, close to 255. As this place is not proper, is there is little bit white, I would assume it would be 100 or something, what value it is. So if I take the IM tool, so this is the picture. So if I go here, is the white 255, 97. This pixel here is 216. This pixel little bit black is 102. So that's how the edge is detected, and the command I have already shown you. Now let's go little bit further. What actually happened background of this code generation? Again, go back and we can, if we just search it online, if we just search the Sobel edge detection, go there, as you can see, what really happened at the background is that there are 2 kinds of Sobel edge detection. One is horizontal edge detection and one is vertical edge detection. What basically they do is that, for instance, think about this image pixel as the A1, this pixel here, the image has been shown here, which I think is a Vietnam War picture. So this pixel number M go to the center point of the kernel, and this top left get multiplied by this number -1, middle left is multiplied by -2, and the bottom left is multiplied by -1. Same goes for the top right. Multiply top right, this pixel is multiplied by 1, this pixel is multiplied by 2, and this pixel is multiplied by 1 again. The middle is multiplied by 0, and this process is carried out to all the pixels, all these pixels. How about when the center pixel is there? So this is center pixel, this value here is out of the image, so it is considered as 0. So if it goes out of the frame, it is considered as 0. So there are two kind of multiplication went through, two kernel. One is horizontal kernel matrix, one is vertical kernel matrix, and that give us this code. Now let's try another edge detection technique. So basically just copy this line of code, change the name to D, same goes the edge, detecting the edge of the B, the grayscale image, just changing the name, pre-width. I get the name from the list, so this is the pre-width. Pre-width edge detection. So here I would just change the value to one row, 4 column. My pixel will be 4. Changing all this, 1 row, 4 column, 1 row, 4 column, 1 row, 4 column. If I run it now, changing the name, I'm sure C, I'm sure D, pre-width image. Let's run it. So as you can see, I've got my 4 picture side by side. So this is pre-width image, Sobel image, grayscale image, color image. Let's just see one image at a time. So I will just say I am sure D is the pre-width image. I'm sure D. Let's run the code. Let's deactivate all the lines at the top, so that way we can deactivate all the lines. Just leave these lines, select all the lines which we want to deactivate, right click, put command button. That will, the code will consider this line as comment, not code. This line need to be deactivated as well. This way of commenting is quite effective because you can use it for debugging, to fault finding. You can use it for fault finding in the code. So if you run, if I just run the code now, here is my pre-weight edge detection. If I deactivate this line comment and no, let's keep it here. I want to show the canny edge detection. I want to show the Sobel edge detection we have carried out previously, but in the array format, where all the image was shown in one figure. So this time I am show C. So this is the canny edge detection. Now I want to compare between Sobel and pre-weight. So I'll do a subplot, copy, paste, subplot, one row, two column. Number one, I want to show the Sobel image. C is the Sobel image as we previously assigned it. Title, Sobel image. The next one as it is, subplot, paste, just changing the number of the column. So number 2, pre-weight image. If I just run it now, let's deactivate this line as well. So comment it. If we just run it now, well, this one need to be changed to 2. So as you can see, this is my Sobel edge detection, this is my pre-weight edge detection. Again, what is pre-weight edge detection? Pre-weight edge detection can be found, just Google it. Pre-weight edge detection image. So the pre-weight goes same like the Sobel, but the kernel is different, the multiplication matrix is different. So this is the multiplication matrix or mask. So this is the horizontal mask, this is the vertical mask. So the horizontal mask is, as you can see, this website. Let's click it. So edge detection. So basically the pixel value is multiplied. So if I open my image, so think about this pixel value, which is the pixel at the left or top left corner. The pixel number is pixel location is 29 in x direction and 23 in y direction, x direction, y direction, 18, 34, 27, and the pixel value is 0. So if you multiply the 0 pixel, so the 0 will be the center one, and all of the neighboring pixel will be multiplied by the following numbers, following pixels. How about the white one? The white one is pixel number 93x 122y. The pixel number is 255. So this pixel will be multiplied by 255 times 0, and the neighboring pixel, which is 110, will be multiplied by this 0. How about the left side pixel? Left side pixel, consider this pixel value is 96 will be multiplied by 0. How about the top pixel? The top pixel is 185 will be multiplied by -1. Top center pixel 180 multiplied by -1. So this way the Sobel this way the pre-weight edge detection is generated in Matlab code. Again, all these things happen at the background. We just write the name and the program would do it. So let's open another edge detection line. We give another variable e equal edge bracket b, the grayscale image we have already assigned RGB to gray, so the b I want to open it as canny edge detection. So b comma apostrophe c a double n y canny edge detection semicolon. This time let's just open this canny edge detection picture first, then we will compare it. So if we just copy and paste, changing the name, comment all this, comment, deactivating all this, run. So this is my canny edge detection. Let's compare 3 edge detection, Sobel, pre-weight and canny at same figure. So again we will do subplot. Let's deactivate this line, but need to change because I have got 3 image, but in this configuration only possible to show 2 image because it has got 1 row 2 column. So how about we increase 1 column 3 column, copy this code. As you can see, I'm trying to copy and paste the code I have already created. The reason behind is that I want to make you a habit of modular programming, where you make one module, then you reuse this module to make another line of code. So this time is column 3. The variable is not d, it is e, this variable. So e title canny image, change the title, canny image. So if I run the code now, basically it will show 3 edge detection image in one figure. Let's deactivate this because I don't want to show this image this time, so just comment it. If I run it now, so I've got 3 image side by side. As you can see, there are subtle change in different edge detection techniques. For instance, in pre-weight edge detection, you can see it has detected the least amount of edges, and the canny edge detection has detected the most amount of edges, and Sobel is in between. There is a difference between these two, Sobel image edge detection and pre-weight image edge detection, and the canny. Canny is different than these two because canny's masking work into canny's masking work little bit different way. Canny edge detection technique differ from the first two. The way is, if you can just Google it, So these are the processes. You can see the canny edge detection happen rather than the one-time kernel implementation, like a vertical kernel and horizontal kernel implementation. It goes through few of these steps. First, start with smoothing with Gaussian filter, then gradient calculation, non-maxima suppression, and thresholding. I'll take a break. I will close this tutorial today, and the next tutorial I will discuss more about canny edge detection and all these processes. Thank you for watching this video. See you next time.